Welcome to this video on the topic of algebra. In this video, we're going to have a look at how we can simplify algebraic expressions using the method called collecting like terms. Like terms are terms that have the same combination of variables. Consider, we have the expression 3x plus 4y take 2x plus 5xy. The terms in this expression are 3x, 4y, minus 2x, plus 5xy. We remember that the minus always belongs to the number it's in front of because a term is separated by the plus symbol. In front of every negative is an implied plus. Now looking at this, we know that like terms have the same combination of variables. What we want to do is we want to identify which terms have the same combinations of variables. If we look at our statement, we have a 3x. A like term to 3x is a term that's going to have the same letter x. In this instance, the like term here is minus 2x. In contrast, we have 4y. 4y does not have the same combination of variables as the 3x's and the minus 2x's. Furthermore, we have 5xy. Notice that the 5xy has an x and a y. This, although it shares letters with the other terms, it's not a like term because it doesn't have the same combination. So the yellow represents the like terms here, the orange represents a term that's not like to any other, and similar with the purple here. Now expressions like this can be simplified using the method of collecting like terms. Collecting like terms involves summing the coefficients of like terms. So what that means is that if we were going to simplify this expression over here, we would collect like terms. So our like terms are 3x and minus 2x. We could simplify this by summing the coefficients. Coefficients being the numbers in front of the variables. So we'd say 3 plus minus 2, and whatever that is, we'd write an x after it, and that would simplify the x's there. So let's have a look at how this is formally done by example. Example 1, simplify. We have 5x, take 3x. We'd like to simplify this using the collecting like terms method. First thing I'm going to do here is I'm going to identify my like terms. Like terms being terms that have the same combination of variables. I have an x here and I have an x over here. Next thing I'm going to do is I'm going to write the coefficients in brackets together. So I'll open some brackets, I'll go 5 plus minus 3. Remembering that in front of every negative symbol we have an implied plus symbol. We don't have to show this, but we can if we want. At the end of the bracket, I associate these numbers being associated with x by just putting the x there. Now, what I'm going to do is I'm going to collect like terms. This will involve just summing. So 5 plus minus 3 is the same as saying 5 take 3, which is the same as saying 2, and we're associated with x. So 5x take 3x can be simplified down to 2x using the collecting like terms method. Alright, let's go to B. For B, we're going to have 5a take 2, take a, plus 3, minus 2a. Now, first step is we need to identify our like terms. I turn my attention to the first term in the expression. It has a's. What I'm going to do is I'm going to underline all of the variables that have this same combination. I see there's a minus a and I see there's a minus 2a. Okay. The other like terms are minus 2 and 3. They don't have variables, but we can still say they're like terms because they still have the same combination even if there are no variables. So it still is a like term. Special in that we call this one a constant, but anyway. Moving on. What I'm going to do is I'm going to write all of the like terms so they're positioned next to each other. I'll have 5a, then I'm going to have minus a, then I'm going to have minus 2a. Those are my a's. Now I turn to my constants. I have -2. I now have +3. Okay, next step. What we need to do is we need to sum the coefficients. Now the first one's interesting. I open the bracket and I write 5. And then I get a little bit stuck. I wonder to myself, I don't have a number in front of the a over here. When this happens, we have an implied number of 1. So it's -1a. So in substitution, I put in -1. Then I put in -2 for the final variable or final term. I associate this with the variable a. Next, I put a plus and I sum my constants. Alright, it's now time to crunch the numbers. 5 take 1 is 4, take 2 is 3. So it's 3a plus -2 plus 3 is the same as saying 3 take 2, so it's just 1. So, in summary, 5a take 2 minus 5a plus 3 take 2a is the same as saying 3a plus 1. The things we need to look out for here are, in front of every negative symbol is a plus symbol, and between every plus symbol is a unique term. When we have a variable with no coefficient, then there's an implied coefficient of 1. And finally, if we have numbers by themselves, they are called constants. They're a term in itself and they are like terms, even though they don't have variables. We still say they have the same combination. Alright, let's go on to some trickier stuff. Let's go example 2. Example 2, simplify. 2r take 3r minus 5r plus r. Notice in this expression it contains all r's. However, some are uppercase, some are lowercase. When we're working in algebra, the case matters. As a consequence, the 2r and the minus 5r are like terms. However, the minus 3 little r and the r, so the little r here, are also like terms, but they're not like terms with all of them. Consequently, we need to rearrange this. So we'll start off with the big r's. We'll go big 2r, take 5r. Then I have the negative 3r plus r, knowing that this is an implied 1r. Okay, next line. What I'm going to do is I'm going to put all the coefficients together. So I'll go 2, take 5, big R, plus, in brackets, minus 3 plus 1 R. Next, I'm going to compute. 2 take 5 is negative 3, and it's big R, plus minus 3 plus 1 is minus 2, so I can change this to minus 2 little r. Thus, simplifying the expression 2r minus 3 little r, take 5 big R plus little r, is the same as writing minus 3r, take 2 little r. So the takeaway here is that capitalization matters. You cannot mix big and little letters. You have to keep them separate as if they're different symbols. Okay, example 3. We are dealing with 5x squared plus 3x plus 2x squared minus 4x. Notice that in the previous examples there were no exponents, also known as powers or indices, in the expressions. Rather, they were all flat, like this guy over here. When we're dealing with these, our like terms are going to have the same combination of variables. When we're looking at 5x squared, it's the same as saying 5xx. And as a consequence, 5xx does not have the same variable combination as 3x. So this results in these not being like terms. So when we look at the like terms here, it's going to be 5x squared and 2x squared. They are unlike terms to 3x and minus 4x. So when we're summing these, we have to sum them separately. So first thing, let's write them next to each other. 5x squared plus 2x squared. Then 3x, take 4x. Summing them together, I open the brackets and I write the coefficients with one another, followed by the variable combination. Plus, and now I compute 5 plus 2 is 7, it's an x squared, plus 3 take 4 is minus 1, it's an x. Now, this over here is not a great convention to use, so what I'll do is I'll modify this. I'll get rid of the plus, I'll get rid of the 1, so it will just be minus x. So we see that 5x squared plus 3x plus 2x squared take 4x is equivalent to 7x squared take x. Alright, final one, let's go B. We are dealing with 7ab minus 7ab plus a minus 2b plus 3a take 3ba. What we want to do is we want to simplify this expression here. Now, first thing we need to do here is it's recommended that you write the variables such that they are in alphabetical order. It's not a rule per se in that you have to do it, but I recommend it because it makes identifying like terms much simpler. So 7 or 7ab, nothing changes there, plus the a, nothing changes. Take the 2b, nothing changes. 3a, nothing changes. However, for the final one, 3ba, in alphabetical order, it's 3ab. Next, what I'm going to do is I'm going to identify like terms. Like terms being terms that have the same combination of variables. We have an ab here, we have a ab over here. We have an a over here, we have a's over here. And then finally, we have the b's. Okay, let's write them together. Done. Next, we're going to start summing the coefficients. I do this using the brackets method. I open the brackets, I write the coefficients, I finish it with the variables. Next, I have the a's. There's an implied 1 in front of this regular a, so 1 plus 3. Close it off with an a, and the 2b is by itself, or the negative 2b is by itself. Okay, I now sum. Minus 7 take 3 gives me negative 10 ab, plus 1 plus 3 is 4a, take 2b. So it can be seen that minus 7ab plus a take 2b plus 3a take 3ba is equivalent to minus 10ab plus 4a take 2b. So the takeaway here is that sometimes our like terms are going to have many variables, hence we say a combination of variables. So in summary, what we had a look at in this lesson was how we can simplify algebraic expressions by the method of collecting like terms. This is done by summing the coefficients of all like terms. Like terms being terms that have the same combination of variables.
Christmas style is ridiculous. Give me